Hi everyone, welcome to FSI 202, how JPMorgan Chase is performing migrations at scale through cloud blueprints and automation. My name is Bernie Hurden, and I'm a Senior Solutions Architect with AWS Global Financial Services. At AWS, we're seeing a pattern where our FSI customers are moving core banking and critical workloads to AWS. We're seeing them designed to scale to support thousands of applications across hundreds of accounts. Unlike their on-premises infrastructure, where developers are limited to a handful of standard technologies, such as a few databases in the compute stacks, when customers move to the cloud, they tend to take advantage of the wide range of services available to help them be more agile. What they find is that their traditional SDLC simply does not work at the scale, and customers need to build robust automation and governance controls in order to be successful at the scale. Last year, we heard how JPMorgan increased their production apps on AWS by 900% through their use of migration events called cloud parties. Today, I'm joined by Raul Arya, Head of Global Technology, Architecture, and Next Gen Cloud, representing the CTO, and James Reed, Head of Engineering and Architecture for Corporate Technology, representing the line of business. And we're going to learn how JPMorgan is building up on that foundation to drive acceleration through opinionated blueprints and automation. Today, we'll learn about JPMorgan's approach to scale, we'll hear about the journey through the eyes of a customer, and we'll discuss how they're enabling foundations for the future. I'm excited to welcome Raul Arya to walk us through this journey.
Thanks, Bernie. Thank you for having me today. My name is Rahul Arya. I represent the JPMorgan Chase CTO office as the Chief Architect for Global Technology Solutions. We incubate all emerging technology initiatives with a key focus on next-gen cloud capabilities as our firm looks past our robust cloud platforms and continues to innovate in cloud capabilities for our future. So today, we're going to cover how JPMorgan Chase is looking at our acceleration of cloud capabilities across the firm. Not just the CTO office, but bringing together all of our lines of businesses and having a clear strategic approach that accelerates these objectives. And then we'll get a little bit deeper into how we think about our cloud acceleration products, aka blueprints, and automation efforts, which my good friend JR will cover today for you. So with that, I want to start with our scale. At JPMorgan Chase, we manage over 27 trillion in asset, which we have under custody. That's actually 6 trillion transactions daily, all underpinning a 52 million active digital customer base with 43 million plus debit and credit card accounts that we manage globally. That requires a heavy investment in technology. As you know, we have over 50,000 engineers across the globe that manage this infrastructure for us, with taking care of 6,000 plus applications. Some of our key statistics on technology alone, we have over 250,000 of end user points with a large scale compute database and storage platform that we manage on behalf of our firm. So this level of scale, business operations, and technology requires a different way of thinking about it and requires a different way of approaching cloud that allows us in the global technology organization to manage that very clearly for the firm and manage our acceleration in a very smart way. That brings me to our cloud strategy and approach. How do we approach cloud over at JPMorgan Chase? Well, we've developed a very clear and concise way of disposing your applications onto our modern platforms, whether it be a single particular cloud platform that we build as self-service or a complex project that you're looking to take to the cloud. We've developed a very smart way of approaching all of those different objectives from a technology perspective to dispose onto a cloud platform. That's underpinned by acceleration framework, which encompasses blueprints, toolings and frameworks, as well as cloud parties. What are blueprints, you ask? Well, blueprints really look at our app architecture reusability and offer that up as a product for our customers, aka the developer. Frameworks allow you to actually automate on those blueprints and be able to go faster on your onboarding journey and take friction away from your journey itself. Cloud parties are really making sure all of our enablement teams come together and accelerate that journey with as zero friction as possible so that our developers have a very clear a crisp experience as they onboard to our cloud platforms. This is underpinned, obviously, by a platform services team that manages security, abstracts away complexity, gives you self-service account provisioning, and manages that platform that's hardened for JPMorgan Chase control requirements. We've also developed your self-service telemetry. We've developed an SRE team that actually manages our operations, any impact to our cloud platform that's taken care of on behalf of our customers, aka the developers again. Now, let me talk about how we actually govern against this strategy and approach. I talked about our scale as being incredibly complex, a global team, different lines of businesses coming together and managing a very smart cloud platform and approach. I've talked about our strategy around this conversation. It's important, as soon as we developed our strategy, to create a cloud center of excellence that governs against our strategy. A little bit about our cloud center of excellence. We call this a cloud design council internally. We've created a council that meets on a periodic basis with subject matter experts, not only from the technology office, but the security office, the infrastructure teams, as well as the lines of business architects and engineering. It was very important earlier on in our journey to make sure that we had representations across the globe with different lines of businesses coming together and sitting on the council, governing our strategy, governing our technology architectural practices, and also giving clear oversight and alignment across different strategies that are going on in the business. This allows us to build consensus, have clear alignment, and then be able to sort of accelerate our product development process, which is directly aligned to our stakeholders in the lines of businesses that are using these cloud products to move their applications into modern platforms. We have a particular focus here on blueprints. Blueprints are important because they give you, they move the conversation from a service by service level dialogue into an app architecture dialogue. What is a web app? What is an ML pattern? How do I build a data platform onto our cloud platforms? How do I move into a microservices architecture? These conversations are highly critical because all of those patterns are reusable. You can reuse a microservice for one particular line of business and apply that across the businesses, and then be able to provide that as a product. We govern that in the Cloud Center of Council. What I'll cover for you a little bit later today is also talk about how we actually develop a product concept and offer these products across the globe to our massive, large-scale engineering bench. So here we are. I've covered blueprints, I've covered our strategy, and productizing these blueprints and automation. Ultimately, we took a step back for when we were trying to go through our journey and try to understand where the opportunity is for us to improve our experience from a customer perspective. What we realized quickly is that cloud in general had lots of manual provisioning, lots of inconsistent deployment, manual compliance all over the place, right? Every different lines of business had a different idea of how to approach cloud. Every different team that was looking at modernizing their application estate had a different idea of a blueprint. But in order for us to make sure that we had a massive acceleration and improve our journey from a few hundred applications to thousands of applications on cloud, it was important for us to have a clear, concise product conversation that offered these products up as self-service and reuse. Well, our global goal was very clear. We wanted to have a cloud deployment for any of our blueprints under an hour, whether it's a microservices that you're trying to build on our AWS platform, or if you're trying to create a web app that you want to basically make sure has all of the compliance built in. You have zero friction going through your operational provisioning accounts, etc. We wanted to make sure all of those frictions were taken away from our end user and customer, and ultimately deploy that pattern into a production environment or a test dev environment within an hour. So with that goal in mind, we went about and started a product engineering conversation with our teams with the oversight of Cloud Center of Excellence. So a little bit about our cloud development lifecycle that I will cover for you today. And this is important for any organization and enterprise trying to accelerate their cloud journey. As I've covered already, the lines of business partnership is key because that gives you clear insight on what the application challenges are from a modernization perspective. That alignment to heads of architecture and engineering sitting in the Cloud Council, Cloud Design Council, and the Cloud Center of Excellence, which I run, and making sure that we are building our product aligned to our customers is step one. But in talking about that life cycle, how do we actually go about building these products? Well, first, you start with the blueprint. A blueprint is an app architecture, as I mentioned already. You identify all the common app architectures across your app estate. We have 6,000 plus applications. Majority of them fall into either a web app, a microservice. Majority of our folks are trying to leverage AI/ML blueprints to take advantage of the modern ML services that are on the cloud platform. Then we go about engineering those blueprints as infrastructure as code. And we can essentially instantiate those infrastructure as code blueprints with the advent of Terraform as a Git repo and basically offer that up as a product. We give them a completely automated deployment cycle onto a test dev account, all underneath a abstracted compliance layer, which takes away all of our basic control requirements governed by our cybersecurity teams. What you end up with is really a clear product set across our blueprints that give you security day one, that give you all of the compliance and security built into these product sets so that you as a developer coming to our cloud platforms already have those topics solved for day one. Now, we've also added resiliency to it, right? So for example, we can leverage chaos services that are generally available as a SaaS product and built those into these product sets, whereas our developers coming in and deploying applications to the cloud can build up a microservice with all of our compliance security built in, checked by Sentinel, governed by a declarative Terraform language, and now they can run chaos experiments onto them to make sure that their resiliency requirements are available and ready for their usage, and we guarantee those resiliency for their applications running on our AWS platform. So with that, we wanted to give you a little deep dive on how we actually think about these blueprints and build them and develop them and engineer them. We partnered with our customer as the lines of business heads of architecture and engineering. And my good friend JR today is going to cover how him and I got together and we leverage our cloud strategy, our approach, our cloud center of excellence in this product construct to go and get really deep into concepts of blueprints, automation, and leveraging cloud at scale. So let me hand this off to JR, who will go deeply into our product and engineering constructs and then cover this for you today. Cheers.
Thanks, Raul. For the next set of slides, I'm going to go into the detail of why the blueprints, what are the blueprints, and how we're building these blueprints. So let's just talk a little bit about why the blueprints. From a line of business perspective, we're faced with the challenge of moving many workloads at scale into the cloud with the proper governance and controls and providing self-service and autonomy for the engineers. So we're really looking to create this flywheel effect, which is basically when good things lead to more good things just happening. In other words of JFK, it's really about how do you create that rising tide that lifts all boats. So we had a choice within corporate technology. Do we want to wait for the tide or help create the tide? So we decided we're going to help create this tide using blueprints and partnering very closely with the Cloud Center of Excellence, working closely with AWS, so Bernie and Raul. So what are the blueprints? So let's go a little bit into an analogy. Think of houses and apartments. Houses, you can change what you want, right? If you own your own house, you can knock out walls, you can put in all sorts of things at your own discretion. I'm not very good at that, so I will have to hire a professional. But when it comes to an apartment, think about apartments. They come with the necessities already baked in: light fixtures, heating, air, doors, locks. And as well in the US specifically, they come with other amenities, useful features like a dishwasher, a stove, alarm system, and refrigerator. And as the owner of that apartment, I don't want every tenant installing all the basic necessities and other useful features that comes into those apartments. I want them to be installed properly, so it's compliant with the laws of the city and the state. So that's where you want to use licensed professionals rather than the tenants actually installing them. So think of the apartment as the blueprint. So let's give a real concrete example. So using microservices as a blueprint as an example, think of Kubernetes, the application load balancer, the Elastic Container Registry, EC2s, and these are all the basic necessities similar to the apartment's light fixture, doors, and walls and sinks and kitchen. Then you want to add amenities like that dishwasher, right? So if you don't have a dishwasher, it's going to take you much longer to actually wash the dishes. Having a dishwasher speeds you up. So we want to provide these same efficiencies to the developer. So service mesh, like Istio, right? This enables easier management of microservices, enabling service discovery and circuit breaking for failed services, fault tolerance, so you secure connections with TLS, traffic routing for zero downtime deployments. This is very similar to that dishwasher providing efficiency for the actual tenant. Then you may enable Calico, which is an improved enhanced network security layer of Kubernetes cluster. So you can go beyond just Kubernetes network policy capability. So this is similar to having the alarm and the fire system that's within your apartment. And then enabling pod identity, right? So finer grained controls that enables least privileged access for your apps, right? So you can map the AWS IAM entities into Kubernetes RBAC to configure permissions for the pods. All of these amenities are things that gets baked into the blueprint, therefore enabling a higher efficiency for the developers. By having a higher efficiency for the developers with governance and control baked in, this is where you can begin to operationalize at scale. And how do you do that? Well, we took several use cases, partnering closely with the CTO, the Cloud Center of Excellence, and AWS, and we brought real use cases around machine learning, microservices blueprint, as well as data lake to really begin this journey on the cloud blueprints that we want to get established. So how do we do that? Well, the first thing you want to do is think of blueprints like products, right? That bounded context that really defines a set of options that you really want to be baked into that blueprint. The combination of services that I just mentioned that's going to provide the efficiency and the autonomy to the developer so they can focus their energy on the actual business logic and value that they're trying to put into these architectures. So you first want to define your blueprints as products. So that's your common use case architectures, which, as you know, microservices, event-driven microservices, serverless microservices, machine learning, and data lake are pretty much your common ones. Then you want to build it. So this is where you want to establish, you build it, you own it, you run it, right? You want to have a cross-functional engineering team that's behind that blueprint, treating it as a product and thinking about customer centricity and thinking about the lines of business that's going to actually benefit from those products so they can scale out their migration into the cloud and taking advantage of it. And then the next thing is enforce. This is where you want to bake the security and the compliance into those blueprints, similar to the apartment, where you want licensed professionals installing things to ensure that it's compliant. So instead of having every engineer installing its own service mesh or its own network security, you bake that into the blueprint so therefore they can immediately take advantage of the benefits that come with that, those additional useful features. And then the last one is you want to automate end to end. It's all about reducing the friction and enabling the engineers to deliver their workloads. So then ultimately you can deliver that business value that allows you then to allow the company to really move forward and really begin to modernize its actual portfolio and different workloads that they're trying to deliver to their end customers. So let's talk about how we take this blueprint approach to the cloud using a real use case. So you heard me mention about the microservices use case. Like what's really in that blueprint. So this is really when I explain about the bounded context. So as you look here at the architecture, you see the services to the left from the AWS cloud in reference to IAM, your secrets manager, your key management service, your platform components. As you look to the top, there are a set of services from a JPM perspective that we have to integrate with, right? So our managed certificate store, our active directory mapping, of course, how we do our deployments from an infrastructure perspective, our artifact repository, our SIEM, our security integration for capturing all of our controls and logs to monitor the controls of those logs and make sure that from a security perspective, there's nothing happening that we need to be paying attention to. The SSO provider and monitoring. And then as you move down, you begin to see the real heart of the actual microservices blueprint. So your availability zones, right? So making sure you have high availability. And then notice we split across those zones, your routable subnet, your non-routable subnet, and then having a routable subnet for your persistent store. So you have a 3-tier sort of architecture. At the heart of this blueprint, you have Kubernetes, right? So that's where you have your actual orchestration and your Kubernetes cluster. And then to your left, you start to look at the additional service that I mentioned earlier. So your service mesh, Caligo for networking, your Gremlin for chaos engineering. And then you see other services like the ability to do messaging. So this is where it's really key, right? So I see microservices as 3 separate products. You have your microservices, which are standard vanilla microservices architecture. Then you have serverless microservices where you may use Lambda. And then you have an event-driven microservices. So this is where you want to bring in Kafka to do your messaging. It's very important. And we wanted to make sure that we didn't want to bake too much into that product, having too many options, because we want to make it very clear what was the bounded context for a given product. So we had the right ownership, the right controls, and the right compliance around this blueprint, which we was treating as a product. So that's really important. It's taking the same approach that you take with your microservices when you're trying to define your bounded context and making sure that bounded context becomes a very important piece to this. And that's what we did as we really begin to think about which blueprints are our products. So how do we do this? Think of the 5 layers of the cloud blueprint layer model is how we think about it. These layers, think of them as like Legos. Each layer is solving a particular use case for that particular layer. So you have your foundation architecture that's around your roles, your users, your configuration, your encryption. Layer 2 is all about the external connectivity, your third-party connectivity, VPC to VPC, and how you connect on premise. So that's your cloud for us to JPMC connectivity, how you're connecting to your private cloud. You have your layer 3. So this is really your different configurations around your VPC. So I shared the one that was for microservices. You actually may have other configurations that you might want to have. And then layer 4, which is really the platform architecture, where you start thinking about microservices, web app, data lakes, and then the other blueprints that may sit on top of the data lake. And then you have your layer 5. That's where the line of business comes in, and they're actually looking to build out a cloud native architecture, leveraging layer 1 through layer 4. And as you look to the right, as you see to the right, you see the actual pieces lit up in gold. Those are the Legos that you want to connect to actually create a blueprint. Each of the blocks within each of the layer comes with a set of controls, a set of governance baked in, along with the services that's necessary to actually implement that functionality. And then you tie it all together by creating the actual final blueprint as a product, which is at layer 4, which then allow the engineer at layer 5 to actually begin to use that product and efficiently be able to move into the cloud without having to worry about layer 1, 2, 3, and 4. Now, the advantage of that, you get modular configuration, you get reusable modules, version control, even how you operate within the Cloud Center of Excellence. It made us really think about how do we organize around these blueprints and these products. You really can take on an agile and lean delivery within your Center of Excellence, loosely coupled. And the most beautiful thing are the last three bullets. 1, we now established our own shared responsibility model within our organization. So now we have a clear understanding what's the ownership of the application at layer 5 and what's the actual ownership of the blueprint layer 1 through 4. And then we can automate and enforce our guardrails and ultimately use GitOps to do full end-to-end automation. So let's talk about actually how you build the blueprints as products. Going from the layered model that I just previously showed you to an actual real implementation is what this slide here is depicting. So It's all about using GitOps principles so we can establish this operational framework that takes advantage of the best practices. So we can do version control, collaboration, compliance, CI/CD. So we can apply this to infrastructure automation. So to your left, you see you have a microservices team and a network ops team. So remember in the layer model, you had your layer 2 and layer 3. This is where within the Cloud Center of Excellence, you actually have a team that's owning layer 1 and layer 2 that's building the reusable module. So in the example here, they own a workspace. That workspace through Git is publishing to the private model registry a VPC version 1.0 of the actual VPC that's needed for a microservices blueprint. Then you have a separate team that's at your layer 4, and they actually have 2 workspaces. So we know that EKS is going to be reusable, right? But remember, I mentioned 2 other products, serverless as well as event-driven. So you want to have a workspace within Terraform that you're publishing out the actual EKS version 1.0 of the module for EKS, right? And that includes your application load balancer. That includes your Elastic Container Registry. This includes the pod identity. This also includes Calico that's actually baking into EKS. And then there's your final workspace, which really represents the product, right? So this product, notice in this workspace, it depends on the Amazon EKS module and the private model registry. And the EKS module depends on the VPC module. And then the microservices product, you also now include your service mesh and you include your chaos engineering. So this is all baked in using the Terraform Hell plugin provider. So now you have a microservices, for example, version 2.0 that's sitting in the private model registry that really represents the product comprised of all the services that's needed that I mentioned in previously. So now you look into the right, this is where your line of business and your engineers can now come in and leverage that product. They don't have to be concerned with EKS. They do not have to be concerned with VPC. They now, within their Terraform workspace, just depend on the version 2.0 product. And there'll be some configurable options in there that they can configure within that product. Once they configure their Terraform configuration, they then now can, through Jenkins, through our pipeline, set up a pipeline that actually now is going to run as a remote backend into Terraform, the actual Terraform configuration that they configured on the microservices 2.0 product. So the beauty here is you can see when that job gets kicked off, it runs the init. So this is where Terraform will pull down the microservices 2.0 product. It's actually going to see what version of the private model registry it depends on. It'll see that it needs EKS 1.0, pulls that down. It sees EKS 1.0 needs VPC 1.0, pulls that down, runs the plan, validate that the plan is with no errors and is accurate. And then guess what? It runs the Sentinel policy checks. These are all the guardrails and security controls that you actually baked into the blueprints, where we're actually using threat modeling to actually do the exercise to understand what are the threats, what are the threat agents, come up with the controls, and then those controls get implemented as Sentinel policy checks. So all those policy checks actually run. When those policy checks pass, then it actually provisions the infrastructure. We just created immutable infrastructure with governance, with compliance, and with all the useful features that the actual engineer needs to now deploy their microservices into. A couple advantages here that you get. One, from a compliance and governance perspective, if we discover a bug, or if we discover we need to upgrade a particular service because of regulatory reasons or compliance reasons or security reasons, guess what? We make that change once, republish it to the private model registry, and then have all the teams or all the workloads that's depending on that particular version to upgrade to the next version. We've now pushed out massive changes across the enterprise just by managing our blueprint as a product. Now, this is very powerful, which then allows us to be able to scale up our migration into the cloud, allows us to move at a rapid pace, but ensure that we have opinionated architectures that has the proper security, compliance, and controls baked into those blueprints. So with that, What are the key takeaways and the key benefits of being able to have this modular design to create pre-built and customizable opinionated blueprints? So let's start with the takeaways. One, you want to avoid death by 1,000 cuts. What I mean by that is if you're not careful, you'll treat each of the AWS services, this is what we initially did, as a separate product, as a separate product. If you treat those as a separate product, then you're leaving it to the actual engineers to combine those products together in order to then build the final product. So this is where you can get into death by 1,000 cuts, and you don't have the efficiency to move at a very rapid pace. The next one is you want to adopt a product-centric delivery model within the Software Center of Excellence, right? So it's all about agile and lean and actually how you build these blueprints, right? How you operate plays a big factor into your ability to scale up. So by having the blueprint as a product, by having the layered model, by having the APIs between each of those layers, which basically becomes Terraform modules that are actually deployed with a clear dependency of how you use that module, reduces the friction across the teams that's within the CCOE so they can move very rapidly to deliver these products to the lines of businesses. And then the third one is really about you got to balance your cloud migration strategy. So you're going to have bespoke projects, right? And these are projects that's going to deliver huge value for the company. And we saw that. But you also want to enable some of your smaller projects because you want to take advantage of the cloud, given what modernization can do for you. So you want to find that balance between your bespoke projects and the blueprints as products, and try to use your bespoke projects actually as a means to drive your blueprints as products. So if you have your very large project, if it aligns with one of the blueprints, that project actually can help mature the blueprint. Therefore, when that project is done, the actual rest of the firm actually benefit from being able to reuse that blueprint. And then you want to make sure, this is really important, build your new muscle memory for the cloud. Training, right? That's something you never want to overlook. Training is really important. And training is just not about getting your certification. It actually brings cultural changes within your organization to think differently about cloud native architectures. And then lastly, the blueprints really give you ability to give the autonomy and self-service to the engineers. The cloud parties that we do are awesome. They were great. We had Gurdeep, who came last year, presented about our cloud parties. Now we're trying to take that next click where we really want to give the engineers the autonomy to be able to move at a rapid pace. So with those key takeaways, you can see the benefits that you really gain, right? You get the ability to do your migration of applications at scale. You then are able to standardize and have a standard way of scaling up your modernization blueprints at scale, because now they're opinionated and they're standardized. You automate compliance and security controls as part of those blueprints. And then you're creating the tooling and you're creating the culture that provides self-service to the developers, ultimately streamlining your entire process to actually get into the cloud. This is the value that blueprints will actually bring to your organization, and this is the direction that we are taking. We're already seeing the benefits, how this is going to speed us up. So look forward to part 2 in our next re:Invent, where we'll come back to you and actually show you a demo and show you actually how we was able to take this approach and really streamline our ability to get into the cloud, to take advantage of what the cloud actually has to offer. So with that, I just want to thank you for joining the session. Thank you for giving me the time to listen to me, Raul, and Bernie to talk about blueprints as products. And don't forget, go fill out those surveys to give us your feedback about the session. Thank you and have a great day.